Hello, good evening everyone. Welcome back to Great Wallah English YouTube channel. I hope everyone is doing great. Before starting, everyone kindly comment that I am fully audible and visible to you all. Good evening everyone. Everyone kindly comment that I am fully audible and visible to you all. Everyone kindly comment. Everyone kindly comment if I am fully visible and audible to you all. Good evening, dear. Good evening. So till last class we have covered some topics of hydrograph. We have discussed what is volume of dry runoff. Okay, how we discuss it, how we calculate it, how we evaluate the volume under the area, volume of your direct runoff by simply finding the area under the direct runoff hydrograph. Okay, we have discussed all these topics. Now we'll move on with further topics. Okay, today in today's class basically we'll discuss with unit hydrograph. Okay, unit hydrograph is one of the most important topics. We'll discuss what unit hydrograph is, what is S curve, all these things we have to discuss today. Okay, perfect. Okay, so audio and video is fully clear now. So let's have a quick recap of yesterday's class, then we'll begin. So yesterday I told you about how to find volume of direct runoff. Okay. So volume of direct runoff was none other than the area under your direct runoff hydrograph. Okay, you simply have to find, yes, you have to simply find the area under your DH, and that area will be your volume under direct runoff, and it is none other than catchment area into effective rainfall depth. So this was our main formula, and three types of questions were framed in examination. So you told me first was when you have triangular DRH, sir, very simple. I will simply apply the formula. I will find the area of this triangle and equate it to area into effective rainfall depth, and we'll get the answer. Okay, sometimes they will ask me catchment area, sometimes they will ask me effective rainfall depth. Okay, like this questions can be framed. Then second question was trapezoidal DRH. In this also, sir, we can easily find the values. And at last we have the basic DRH in which ordinates were given to me. So I will use the trick. Okay, I will use this trick here. I will use simply the sum of ordinates. Okay, this trick I will use, but this trick was, sir, only for this trick will be only used when the duration between these ordinates is constant. Okay, when this duration between the when the duration between these ordinates is constant, 1 hour like that. Okay. Okay, good evening Ajay, good evening. So this was important. So this was very, very important. I hope this is clear to you. So now we will in last class we have solved some questions. Okay, I hope you remember the questions. Okay, I hope you all remember these questions. This we have discussed. In last class we have discussed what unit hydrograph is. See, unit hydrograph is a kind of DRH only. Unit hydrograph is a kind of DRH only which is resulting from 1 centimeter effective rainfall depth. One effective rainfall depth is 1 centimeter. That is your unit hydrograph, and that too in 1 hour. If 1 hour, then it will be called as 1 hour unit hydrograph. When this effective rainfall depth will happen in 2 hour, then I will call that unit hydrograph as 2 hour unit hydrograph, like that. Okay. 3 hour unit hydrograph means D hour unit hydrograph means that 1 centimeter effective rainfall depth was there in D hour. So this we have understood. And in last class, sir, you told me the assumptions. In this, the main assumptions were, sir, time invariance and linear response. Okay, two main assumptions were there. The first one was time invariance, and the second assumption was your linear response. Time invariance means that no matter whenever rainfall happens, sir, but whenever it will happen, sir, it will take the same shape. Okay, hydrograph will take the same shape. This we have discussed. And in linear response, sir, you told me that when effective rainfall depth will increase, in proportion your discharge will also increase. If let us say if effective rainfall depth is doubled, the discharge will be doubled. Okay, so all these things we have discussed. Yes, great. So now we'll move ahead and discuss the further topics. Okay, sir, no problem. So this was the last class, and in today's class basically we are going to discuss the applications of unit hydrograph, why we are interested in this one. Then we'll discuss unit hydrograph of different durations, how we will convert one duration unit hydrograph into another one. Then limitations we'll discuss. What is synthetic? See, these are not important, so we'll skip it. These are not important, but yes, I will tell you something about synthetic and instantaneous one. Okay, now, so factors we have already discussed. Yes, today we will be discussing one very important formula. Okay, today we will be discussing one very important formula. Wait a second. Yes, this is the important one. Yes, we will discuss this formula first. See, you need to understand one thing. See, before moving ahead, let me solve a very simple question. Okay, let me solve a simple question. See, sir, you have told me that DRH ordinate, sir, DRH ordinate will be unit hydrograph discharge multiplied by effective rainfall depth. Okay, sir, DRH ordinate will be unit hydrograph ordinate into effective rainfall depth. Listen very carefully. This is very, very important. Okay, sir, why? Because we have discussed one assumption which was linear response. Okay, we have discussed one assumption in the last class which was linear response. Sir, you told me, let me take one example. With that example, it will be very, very clear to you. Okay, with that example, it will be very clear to you. Sir, let us assume we have a unit hydrograph. Let us say we have a 2-hour unit hydrograph. Okay, we have a 2-hour unit hydrograph. Convert it to 5 centimeter. Convert it to 5 centimeter DRH in 2 hours of 2 hour. Okay, that means the rainfall duration is same. No problem, sir. I will convert it. Definitely, I will convert it. So the unit hydrograph is given to you like this. Okay. Wait a second. Okay, let us say the unit hydrograph is given to you like this. Okay, sir. So this is my unit hydrograph. Okay, sir. Tell the values. So here I will be having time and here I will be having the ordinates. I will call that ordinates as U. U means unit hydrograph ordinates, or simply you can say discharge values. So time is 0, 1 hour, 2 hour, 3 hour, like that. Okay, sir. The value of discharges are 0, 5, 7, 15, then 12, 8, 12, then we can say 3, and then 0. So these are the value of 2-hour unit hydrograph. Okay, these are the, see, we have a 2-hour unit hydrograph in which we have these values. Okay, now if I want to convert this into 5 centimeter DRH, sir, see, one thing you are saying here is that, sir, in this graph, sir, this is unit hydrograph, which means, sir, this is a unit hydrograph, which means we have 1 centimeter effective rainfall depth. Sir, we have 1 centimeter effective rainfall depth in 2 hours. And the graph is going from 0 to 6 hour. Graph is going like this. Okay, so the graph is going like this. From 0 to 6 hour. Okay, graph is going like this. Yes or no? So graph is going like this. This is my 1 hour unit hydrograph. Okay, sir, this is my 1 hour unit like this. Okay, from 0 to 6. Okay, sir, no problem. Now you are saying, see, this is the input is 1 centimeter, and the these are the value of discharges, 0, 5, then 7, then 15, 12, like this. These values are given to me. Okay, now if I want to get the value for corresponding to 5 centimeter, sir, if I want to get the value corresponding to 5 centimeter, what I have to do? I will increase this 1 centimeter multiplied by 5. Yes or no? I will multiply it by 5. Then obviously the input will be 5 times. Now if my input will be 5 times, the graph will also increase 5 times. Yes or no? Sir, this is 2-hour unit hydrograph, but this is 2-hour 5 centimeter DRH. This is 2-hour 5 centimeter DRH. 5 times of that. Okay, we have to do 5 times. Yes or no? Tell me, we have to do 5 times. So if I want to find 5 centimeter DRH, sir, what I have to do? Sir, I have to simply multiply by 5. Why? Sir, because you have told me in the last class about linear response. Okay, in the last class you told me about linear response, or you told me that when effective rainfall will be doubled, discharge will be doubled. When effective rainfall will be 5 times, It will be 5 times. So simply you are saying, if unit hydrograph ordinates are given to me, I will multiply unit hydrograph ordinates with effective rainfall depth, which is none other than 5. I will multiply these values with 5. Okay, so multiply it, you will get 0. 5 5 is 25. Multiply this 35. Like this, you will get all the values. 12 5 is 60. 3 5 is 15. Like this. Okay, so this is your 5 centimeter DRH. So if I, overall you are saying DRH ordinate will be unit hydrograph ordinate into effective rainfall depth. Similarly, if DRH ordinate is given to you and if you want to find unit hydrograph ordinate, you will divide it by effective rainfall depth. Okay, if you want to come from here, you will multiply, but if you want to go from here to here, you will divide. Okay, so remember it. So I hope this is very clear to you. Yes or no? Okay, test series will start soon, don't worry. Tell me, is this thing clear? If this thing clear, then we'll move ahead. With the next topic. So this DRH and UH conversion should be very clear to you. It is simply based on the factor of effective rainfall depth. Okay, yes, perfect. Now DRH URH conversion is clear to me. Now DRH URH conversion is very clear to me. Now I will give you one question, which is your obtaining of DRH by method of superposition. Okay, so this is also very important question. Let us again assume, let us again take an example. With this example, it will be very clear to me what is the meaning of DRH, how we obtain it by method of superposition. Okay, see, listen very carefully. This is very important. This is also important example. So again, let us take 2R unit hydrograph. Okay, so 2R unit hydrograph for a basin is as follows, which is given to me, is as follows. Okay, so I will take the same values, sir, no issues. 2R unit hydrograph for a catchment area is as follows. Okay, it is given to me. The time values are given to me, sir. 0, 2R, 4R, like that we have it. Okay, 6, 8, 10, and the discharge values are given to me as 0. Okay, I can write the same values again, no problem. We can write the same values, 0, 5, 7, 15, 12, 30. Okay, I will write the same values, 0, 5, 7, 15, like that. Okay, not 12, 15, 6, 0, like this. Okay, so this is my time, sir. This is my time, and this is my unit hydrograph ordinates. Now sir, you need to understand one thing. So this 2R unit hydrograph thing is given to me. Now what happened, sir? Now what happened in my catchment area? Now what happened, sir? Now what happened in my catchment area, sir? A rainfall happened. Now question is saying, in this basin 4R rainfall happened. In this basin 4R rainfall happened or occurred, whose intensities are given to you. Occurred, and intensities are given to you like this. Okay, intensities of rainfall are, let us say, in the first R. Okay, these are the intensities of rainfall which are given to you. Let us say the intensity of rainfall is, let us say, 5 centimeter per hour, and this is your 7, or let us say 3 and 5. Let us say 3 centimeter per, obviously this is intensity, and here it is time, 0 to 2. So this is given to you in the question. Okay, so what I will do, this is the total rainfall. You need to understand one thing. This is the total rainfall in this catchment, in this basin. 4R rainfall occurred. 4R rainfall occurred like this. Okay, so now find the resulting DRH. find the resulting DRH due to this storm. How I will find it? How I will find it, sir? Okay. So this kind of rainfall has happened. How I will find it? So what I will do here? Yes, irrigation will start after this. Don't worry. After this or in some sequence, it will happen. Don't worry. Now, sir, we need to understand in the first second hour. Sir, in the first second hour time, in the first 2 hour, sir, in the first 2 hour and in the second 2 hour, there are two 2 hours duration. Okay. Sir, there are two 2 hour durations. Okay. The first one is, in the first one, if I want to find effective rainfall depth, okay, how I will find it? See, phi is also given to you in the question. Phi will also be given to you in the question. Let us assume the value of phi which is given to me in the question is, let us say the value of phi which is given to me in the question is 0.5 centimeter per hour. That means in every hour, 0.5 centimeter water is going into the ground. Okay. So effective rainfall depth, if you want to find, what I will do, effective rainfall depth, you all know, total rainfall minus infiltration, P minus phi t. P minus phi t. So in the first 2 hours, the total rainfall is 3 centimeter. The total intensity is given to me as 3 centimeter per hour. Sorry, sir. The total intensity is given to me as 3 centimeter per hour. So this total area will be, this is 3 centimeter per hour and this is 2. Yes or no? 3 and 2. So the total rainfall will be 6 in the first 2 hours. So in the first 2 hours, the total rainfall is 3 centimeter per hour into 2. That is total 6 rainfall is there. 6 rainfall. Yes or no? Minus phi t. Phi is what? Phi is what? 0.5. Okay, sir, 3 centimeter rainfall per hour is happening and that too for 2 hours. So in the first 2 hours, total 6 centimeter rainfall occurred. And phi t is what? Sir, 0.5 centimeter water is going into the ground every hour. So in 2 hour rainfall, so in 2 hour rainfall, the value of infiltration will be, you will simply multiply. Okay, we are evaluating for 2 hours. So 3 into 2, 6 total rainfall. 0.5 into 2 is 1 infiltration. So 6 minus 1 total rainfall infiltration, you will get runoff, that is 5 centimeter. So in the first 2 hours, the effective rainfall depth is 5 centimeter. Similarly, in the second one, the total area of that is 5 into 2. Total rainfall is 5 into 2. Then 0.5 into 2. Okay. See, phi index will be same. Sir, phi index 0.5, that will be same. Phi index will be same. Yes or no? Phi index thing will be very, very clear to you. So this is the infiltration and this is the total rainfall. So 10 minus 1 is 9 centimeter. Okay. So what we need to understand is, sir, we have a 2 hour rainfall which is having effective rainfall depth of 5 centimeter, and we are again having a 2 hour rainfall again which is having effective rainfall depth of 9 centimeter. Yes or no? Okay. Tell me, this thing is clear? Perfect. Now, if I will draw a graph here, sir. Okay, sir, if I will draw a graph here, sir, you need to understand, if we have, sir, 1 centimeter rainfall, this is 1 centimeter rainfall which is happening for 2 hours. Listen very carefully. Sir, if we have 1 centimeter rainfall which is happening for 2 hours only, you will get this unit hydrograph from 0 to 10. You will get a unit hydrograph from 0 to 10. Yes or no? It will increase from 0, 5, 7, 15 like this. It will go and it will end on 10. This is 0, this is 10. Okay. Clear? Simple. Now, see, sir, in actual practice, rainfall is not happening for 2 hours. In actual practice, rainfall is happening for 4 hours. So what I have to do? I have to do 2 hour rainfall again. Sir, this is only 2 hour rainfall, and because of this 2 hour rainfall, this is the effect. But this is 1 centimeter, sir. This is 1 centimeter. Now, I have started rainfall again. Sir, I have started the rainfall again because I want rainfall happens for 4 hours. Because I want rainfall happens, total duration of rainfall is 4 hours. Okay. So again 2 hour rainfall is there. So now when 2 hour rainfall again is there, then I will get same kind of hydrograph again. Yes or no? Tell me. Sir, I will get same kind of hydrograph again or not? Why? Because sir, you have told me you will get same kind of hydrograph, because sir, you have told me the shape of hydrograph remains same irrespective of the time when it occurs. Sir, no matter what will it, if it occurs at 0 time, if it occurs as 2 hour, then also you will get the same kind of hydrograph. Okay. So the values which I will get, see, in the first hydrograph, the values are starting from here 0. 0 is at 0 hour. But in the second hydrograph, 0 is at 2 hour. Then it is increasing. Okay. So sir, you are saying if I want to draw another unit hydrograph, this is your first unit hydrograph. If I want to draw another hydrograph, unit hydrograph, I have to lag it. I have to lag it by 2 hours. I have to lag it by 2 hours. Okay. Lag it by 2 hours. I have to lag it by 2 hours. Okay. I will start it from here. So I will lag it by 2 hours. It will be 0. Lag it. Okay. So in front of 2, you will write 0. In front of 2. Sir, in the first one, 0 is at 0, but in the second one, 0 is at 2. Then 5 will shift. Similarly, 7 will shift. 7 will come here. 15 will come here. 6 will come here. And this 0 will come here. So it will be going from, so the first unit hydrograph is from 0 to 10, but the second unit hydrograph is from 2 to 12. When you have shifted by 2 hours, then this will be from 2 to 12. So first hydrograph is from 0 to 10, and the second hydrograph is from, second unit hydrograph is from 0 to 12. Okay. Clear? Now, sir, in the first 2 hours, the effective rainfall is 5. The effective rainfall is 5. So I will make it 5 times. So I will make my input 5 times. Okay. This is 5 centimeter. Yes or no? And this is 1 centimeter only. So 1 centimeter effect is there. So what I have to do? I have to increase the first unit hydrograph only by 5 times. I have to increase only the first unit hydrograph by 5 times. Okay. And in the second 2 hours, the effective rainfall depth is 9 centimeter. The effective rainfall depth is 9 centimeter. Okay. 9 centimeter. So I will increase the second unit hydrograph 9 times. I will increase the second unit hydrograph. Yes or no? 9 times. This you need to understand. So sir, what you are saying, in the first 2 hours, this is representing the effective rainfall, or you can say this is representing the effect in the first 2 hours, and this is representing the effect of rainfall in the second 2 hours, in the next 2 hours. Okay. Tell me this thing. Sir, firstly, I have to increase this value by 5 times, and secondly, I have to increase this graph by 5 times. So I will write here, what I will write here, sir. Wait a second. Yes. Sir, I will write, this is what? This column will be 2u1. Sorry, 5u1. This column will be 5u1. And this column will be 9u2. I have to increase this value 5 times because, sir, rainfall if you will see, the effective rainfall depth in the first 2 hours is 5 centimeter. So I have to increase this effect by 5 times. Why? Because if 1 centimeter effect is this, then obviously 5 centimeter effect will be just 5 times. Okay, so multiply these values by 5. This is 5. 5 5s are 25. 7 5s are 35. Okay, 15 5s are 75, like this. You will get all the values. Okay, so this is 0, 25, like this. It will increase. This is the green line. Or let me show it by green line only. Okay, see, if I am using green here, or should I use white? Because I have used white color here. So obviously we should use white. Then 0, 0, 25, 35, 75, 30 and 0. 30 and 0. Now I have to multiply this second unit hydrograph by 9. Because in the second 2 hour, the effect is 9 times. The effect is 9 times. And it is starting from 2 to 12. It is going from 2 to 12. So multiply this by 9. 0. Multiply this by 9. Okay, multiply this by 9. 7 9s are 63. 15 9s are 135. 6 9s are 54. then 0 9 is 0, like this. Okay, understood? Now if you want to find the total effect, now if you want to find the total DRH, if you want to find the combined DRH by method of superposition, if you want to find the combined DRH, if you want to find the combined DRH, if you want to find combined DRH because of both the rainfalls, because of this entire rainfall, because of this entire rainfall, then what I have to do? I have to simply sum it up. I have to simply sum it up. Okay, I have to simply sum it up. So sum of the values which you are getting here, sum of the values 0 plus 0, 25 plus 0, this will be 80, this will be 138, like this you will get. Okay, like this you will get the values 165, 54 and 0. Okay, so this is the combined graph. This is the combined graph. This is the combined DRH. Sir, this is the combined DRH because of both these rainfalls. Because of both these rainfalls. Okay, so when both these rainfalls occurs, first for 2 hour, then next second hour rainfall is happening, then if we want to find the combined effect, this is how I will do it. Okay, so this is the method of superposition. Is this thing clear? This is the method of superposition. So first, unit hydrographs are there, we will multiply it. So basically we have used this concept only. Basically we have used this concept only. This was for single rainfall, when we have single rainfall. Okay, sir, this was for superposition when we have two rainfalls. We have one rainfall, we have another rainfall. Sir, immediately, sir, you have two rainfalls. If rainfall lag was also there, if there was also, sir, let us assume there was time lag between these rainfalls, then also we can do it. We will make first rainfall here, then we will make the time gap, then I will make again rainfall, I will increase it, I will increase this one, I will start my second hydrograph from there only. I will increase my start my second hydrograph from, I will start making my second hydrograph from the moment the rainfall has started. Okay, I will start my hydrograph from the moment the rainfall has started. Yes or no? Tell me if this thing is clear. So when you have two rainfalls, this is how you multiply your unit hydrograph to get the combined DRH. Okay, this is 5U1, this is 5U1, the first one, and this is 9U2, and this one, this yellow graph is your U1, and the second yellow graph is your U2. Is this thing clear? Tell me. This is very important. Questions have been framed in GATE examination from this only. Questions have been framed from this in GATE examination. So tell me, is this thing clear? Then we will discuss the new topic. Now FRH and UH conversion. Okay, very important. Multiple questions have been framed in GATE examination from FRH to UH and UH to FRH. Okay, U2. What would be the effective rainfall depth for combined DRH? See, for it is not like that. I will say that that is the total, this is the combined DRH, and for that the effective rainfall depth is 14 centimeter. We will combine it simply. Okay, U2, what is U2, sir? I will let you know, don't worry. See, you need to understand one thing. See, we have a catchment. Yes, sir, we have a catchment. Okay, sir, let us say it is 10 a.m. in the morning. And at 10 a.m., sir, 2 hour rainfall is there. Okay, so obviously your rainfall will happen from 10 to 12. Okay, sir, let us say it is 8 a.m. Let us say it is 8 a.m. and rainfall happened for 2 hours. Okay, and you need to understand, because of that, wait a second. Okay, let us assume this example. With this, it will be clear. 10 to 12. Listen very carefully now. Sir, from 8 a.m. to 10 a.m., we have 2 hour rainfall, and let us say only this is there, this is not there. Now, if this rainfall is there, obviously some discharge will be, some flow of water will be reaching your outlet, yes or no? Runoff will be there, yes or no? Understood? And let us say this rainfall is not there now, only this rainfall is there. Let us say only we have 2 hour rainfall when at 10 a.m. it has started and it will end at 12 p.m. Then obviously you will have runoff. Okay. So now, if you want to find the direct runoff hydrograph from this one, what you will do? You will make a unit hydrograph. You will make a unit hydrograph like this. You will make a unit hydrograph for this one. You will make a unit hydrograph for this one and multiplied by effective rainfall depth. Okay. Now, if this was not there, only this rainfall was there, but it has started from 10 a.m. This is 8 a.m. Now, if it has started from 10 a.m., then obviously I have to draw unit hydrograph from here, and I have to multiply this only by effective rainfall depth. Okay. So when your rainfall starts, you need to understand these are two different rainfalls. First rainfall, second rainfall. First rainfall runoff, second rainfall runoff. First rainfall runoff, how I will calculate? First rainfall runoff? I will multiply unit hydrograph by effective rainfall depth. Second rainfall direct runoff, how I will find? Second rainfall runoff, how I will find? So I will find by multiplying the unit hydrograph by its corresponding effective rainfall depth, which is 9. So this is the effect because of first rainfall. This is the effect because of second rainfall. Individually, assuming that they are not interfering with each other. Okay, we are assuming that this rainfall is not interfering with this one and this rainfall is not interfering with this one. Okay. So the total water which you will receive at the outlet will be this. So the total water which you will receive at the outlet will be this. Okay. Okay, DCET, tell me, is this in clear? So, sir, we are studying the combined effect of two rainfalls. This is the first rainfall. If this was not there, we would have got only this yellow and white graph only, 5v1 only. But again, we have second rainfall, so we have to consider it. We will solve it separately. Okay, we will solve it separately and we will add at the end. We will add it at the end. So this is known as method of superposition. Method of superposition means we will consider only one effect. We will consider one effect and we will consider another effect. At the end, we will combine both the effects. This is known as method of superposition. Superposition means we are considering two effects, but we will solve them individually. Okay. So this is the thing. I hope it is clear. So this is because of a single rainfall, and this is because of two consecutive rainfalls. Okay, so I hope this is clear now. Okay, so now we'll move to FRH and DRH thing. Now we'll move to, similarly, you need to understand, let me show you some examples. Similarly, what you can do is, let us say the rainfall is like this now. Let us say, sir, rainfall has happened here. So try to understand this thing. So let us say rainfall has happened here. Then let us say rainfall has happened here. So what I will do now, and let us take an example in which, actually these are 1 centimeter like this. Okay. So in this one, what I will do, see, this is the unit hydrograph. So I will draw this unit hydrograph from here. And this this rainfall is starting from here. So I will draw unit hydrograph from here. I will draw similar unit hydrograph again and again because the duration of rainfall is same. Now, this is 1 centimeter effect. This is 1 centimeter and its effect. This is 1 centimeter and its effect in the outlet. Now let us say the effective rainfall depth in the first case is, let us say R1. And let us say effective rainfall depth in the second case is R2. So what I will do, I will multiply this by R1. This is R1 U1, and this will be multiplied by R2 U2, and the combined value which you will get will be, when you will combine it, the graph which you will see will be like this. the graph which you will see will be like this. It will decrease. See, at this point you have 0. At this point you have 0. So you will get the graph like this. The combined value this only. This has ended. It has started. This is the combined value. Okay. This is the combined value. This is the combined graph. So I hope this is clear. This is the combined graph. Now same thing. When you will add it, when it has ended, then it has started. So obviously they will be separated. No, nothing is common now. Sir, here in this one, sir, 3 rainfalls are there. 3 consecutive rainfalls of 2R are there. So this is the hydrograph for the first one. Sir, this is the hydrograph for the second one. Sir, this is the hydrograph for the third one. This is the hydrograph for the third one. Okay. Now let us say in the first duration, the effective rainfall depth is, let us say, R1. In the second duration, let us say the effective rainfall depth is R2. And in the third case, let us say it is R3, effective rainfall depth, P minus phi T. Okay. Then what I will do? Sir, I will multiply the first one. I will multiply the first one by R1. I will multiply the second one by R2. And I will multiply the third one by R3. Okay, similar to the ratios. Then I will combine it. Till here it will be same. It will increase. And it will decrease like this. Okay, so this will be your combined DRH. Okay, so I hope this thing is clear. This is the meaning of superposition. Okay, so this is the meaning of superposition. Let us say this is your first DRH unit hydrograph, and let us say this is your second unit hydrograph. Rainfall is started from this point. You will draw it again in a similar fashion. That means, wait a second. Here rainfall is started at this point of time. What I will do now? So let us say effective rainfall depth in the first duration is R1 and in the second one it is R2. I will multiply it. This graph will be multiplied by R1 and this graph will be multiplied by R2. Then I will, sir, combine it. When I will combine it, I will get this value. Okay, it will increase, then it will decrease again. It will again increase and it will go like this. Okay, sir, it will increase. It will start decreasing. It will increase again. And it will go like this. Yes or no? Tell me. So these are different categories of superposition. R1 U1 plus R2 U2 like this. Yes, if they are not giving the graph, then what they will give? Yes, you are right. If they will not give you the graph, they will say that 4 hour consecutive rainfall like this. In this they will say 4 hour consecutive rainfall happens. 4 hour consecutive rainfall happens for and intensities of rainfall recorded will be 3 centimeter per hour in the first 2 hours and 5 centimeter per hour in the next 2 hours. Like this they will give you. Okay, like this they will tell you. So they will write the statement for this one. Okay, and they will give you the average loss 5 values. Sometimes you will not be required to find the effective rainfall depth. Sometimes effective rainfall depth will be given to you directly. Okay, now I hope this superposition thing is fully clear to you. Okay, now I will move on to FRH, DRH and UH. Okay, so this is the combined effect. This is how, see, why we are able to multiply and why we are able to add all these things. Why we are able to multiply and add? Because of one assumption which we have assumed, which is none other than linear response. Okay, sir, because of linear response only we are able to add the two inputs to get the corresponding two outputs. Input is effective rainfall depth and output is your discharge at the outlet. So we can add also, we can multiply also. So multiplication and addition is possible only because of linear response. We have assumed linear response. If this would have been a square, then obviously you could not add it. Okay, then obviously you could not add it. Okay, now, sir, we know one thing. Now this is most important. Now the topic which you have arrived is the most important one. This is the most important topic. Okay, sir, tell me. Tell me the most important topic. You know one thing. You know one thing that FRH ordinate. You know one thing that FRH ordinate is DRH ordinate plus base flow. You all know this thing. DRH ordinate plus base flow. You all know this. Simple, basic thing. Now, this is the first equation which we have studied at the starting of the chapter. Okay, this was the very first, you can say, equation which we have studied in the beginning of hydrograph. Now, sir, today we have discussed. Today we have discussed flood runoff hydrograph discharge. Discharge ordinate means y-axis value is discharge. Okay, ordinate means the value on y-axis which is discharge. See, DRH ordinate is unit hydrograph ordinate into effective rainfall depth, excess rainfall depth. Yes or no? Yes or no? Tell me. Very important formula. This is very, very important formula. But sometimes what will happen? Sometimes what will happen in the examination, effective rainfall depth will not be given to you, like in this question. Okay, in this question, sir, you can see that effective rainfall depth is not given to me directly. So how I have found out the value of effective rainfall depth? Tell me. How I will find it? I will simply subtract infiltration from total precipitation. Okay. Only this much is important here. So if you are able to understand this, nothing will happen. Yes. So you are saying, sir, flood runoff hydrograph ordinate is equal to unit hydrograph ordinate, but sometimes effective rainfall depth will not be given to you. So how I will find the runoff value? Simply subtract infiltration value from total precipitation. You will get effective rainfall depth like this. But this is for isolated storm. This is for a storm which is isolated. Single storm is there. When you have single storm, okay, we don't have 2 or 3 consecutive rainfalls. For that, it is not suitable. This formula is only suitable for, sir, this formula is only suitable for your isolated storms when you have a single storm. Okay, like this. So very important formula. Now in examinations, you will see, basically 2 types of questions are framed. See, when you will read out this equation, you will see 6 things are given to you. One is FRH ordinate, one is unit hydrograph ordinate, then total precipitation, pi value, duration of rainfall, and base flow. 6 things are there. And obviously in examination, you will see most of the questions are based. See, 6 things are there. 5 will be given to you and 1 will be asked. Generally, they will give you unit hydrograph ordinate and they will ask you flood runoff hydrograph ordinate. Sometimes they will give you this thing and they will ask you unit hydrograph ordinate. Mostly you will see that all the questions will be based on this. Okay, so basically you have 2 types of question in examination. Sir, in examination, basically we have 2 types of question. Okay, sir. Type 1 question is unit hydrograph peak or any ordinate is given to me. Unit hydrograph ordinate is given to me, is given. And type 2 question is in which flood runoff hydrograph ordinate is given to you. In which flood runoff hydrograph is given to you. Okay, so when unit hydrograph ordinate is given to me, I will multiply it by effective rainfall depth to get the DRH ordinate. This we have understood. I will multiply it by effective rainfall depth to get the DRH ordinate, and at last I will add base flow in it. At last I will add base flow in it to get the FRH ordinate. Yes or no? Simple step, or simply use this equation. Put unit order of air, effective rainfall depth, add base flow, first multiply then add, first multiply then add, and you will get the FRH ordinate. Simple. Okay, simple logic. And second type of question which you get is you will be given FRH ordinate. Now what we will do? From FRH you will subtract base flow. From FRH you will subtract base flow to get DRH ordinate. To get DRH ordinate. Now I have got the DRH ordinate. Now divided by effective rainfall depth. Divided by effective rainfall depth to get the unit hydrograph ordinate. So in type 1 questions, unit hydrograph ordinate will be given to you. You will be asked to find FRH ordinate or DRH ordinate. And second type of questions will be in which FRH ordinate will be given to you. You will be sometimes asked DRH ordinate, and sometimes you will be asked unit hydrograph ordinate. Okay. So these two types of questions will be framed. Yes. So let us solve the questions now. I hope you have written all these things. Okay, I hope you have written all these things. Very, very important. Okay, so you have written till here. Now we'll solve questions. Okay, now we'll simply solve some questions, very important questions. Okay, now we'll discuss the questions. Now, see, this is the question which has been asked in your GATE examination. And this is the question which has been asked in your GATE examination. So will you be able to solve this one? Same type of question. This is a question which has been asked in your GATE examination. Okay, so we'll solve it. An effective rainfall of 2 hour duration produced a flood runoff hydrograph peak of 200 meter cube per second. They are saying two things are there. Duration of rainfall is 2 hour and flood runoff hydrograph peak is given to you. Flood runoff hydrograph peak is given to you as 200 meter cube per second. Okay, so in this question they are giving you, tell me this, is it type 1 question or type 2? They are giving you flood runoff hydrograph ordinate. They are giving you flood peak, which means this is type 2 question. Okay. Okay, so T is equal to 2. FRH is equal to 200 meter cube per second. Now the flood hydrograph has a base flow is also given to me as 20. Okay, sir, base flow is given to me as 20. No problem, sir. Now if the spatial, wait a second. Yes, now if the spatial average rainfall in the watershed for duration of 2 centimeter, okay, so total rainfall is 2 centimeter, and the average loss rate, that means the phi index, is given to me as 0.4 centimeter per hour. Now the peak of 2 hour unit hydrograph in meter cube per second per centimeter up to 1 decimal places. Okay, see, so I will solve this question. and also draw the diagram simultaneously so that you are able to understand it also. Sir, this is the flood runoff hydrograph. Need to understand. This is the flood runoff hydrograph. This is the flood runoff hydrograph with a peak value of 200. Okay, this total value, this peak value is 200. Okay. Now, if I will subtract 20, if I will subtract the base flow, if I will subtract this base flow, what I will get? Out of 200, if I will subtract 20, I will get 180. Yes or no? This is 180. This is 180 meter cube per second. Yes or no? This is the base flow. This is base flow, which is 20. Okay. So I will write the basic equation which you have told me, sir. I will write the basic equation. I know the formula. FRH peak is unit hydrograph peak into effective rainfall depth plus the base flow. Okay. Simple. Now what I will do? FRH peak is given to me as 200 meter cube per second. Unit hydrograph peak I have to find out. Unit hydrograph peak I have to find out simply. Okay. Now, sir, P is how much? Sir, 2 centimeter. Total rainfall is 2 centimeter. In every hour, 4.4 centimeter water is getting lost. 0.4 centimeter water is going into the ground in every hour. Okay, this is phi. This is P, this is phi. T is total duration rainfall is 2 hours. So if 0.4 centimeter water is going into the ground in 1 hour, then in 2 hours, 0.8 will be lost. So 2 minus 0.8 is 1.2. 2 minus 0.8 is 1.2. That means effective rainfall depth P minus phi T is 1.2 centimeters. No issue, sir. So when from this 200 I will subtract 20, I will get DRH ordinate. I will get DRH ordinate. Only this graph is DRH. Okay, simple. Now bring it here. Unit hydrograph peak will be what? Will be DRH peak divided by effective rainfall depth. Okay. Sir, 200 minus 20 is 180. 180 is what? 180 is DRH peak divided by 2 minus 0.8, which is 1.2, which is your effective rainfall depth. Now, you need to understand, I will divide this value. Okay. I will divide this value by 1.2. I will divide this value by 1.2 and I will get a value. Divided how much you are getting? I will get this value. Sir, this is my unit hydrograph. Sir, this is my DRH when you are considering it from here, but FRH when you are considering from total base, and this is your FRH. Okay. So this will be coming out to be, tell me how much it is coming. It is coming out to be 150 meter cube per second per centimeter. Meter cube per second per centimeter. So up to 1 decimal base, if I want to write the answer, I will write it 150.0. Okay. Will you be able to solve this? Tell me, will you be able to solve this? So we have used a simple concept how to derive unit hydrograph from FRH. 180 divided by 1.2. 180 divided by 1.2 will be 150. Yes, perfect. This is one of the most important questions. One of the most important questions of your GATE examination. Okay. One of the most important questions. Yes. Now I will give you one more question. Let me see if you are able to solve it or not. Okay, I am giving you one more question in which we will do the reverse. So this was your type 2 question. Sir, this was my type 2 question. Basically, FRH peak was given and unit header of peak was given to me. Okay. Now in gate examination, different questions are there. Okay, not this one, because in this, okay, complete question is not there. Okay, I will give you one more question from gate examination. So they are giving one more question. A triangular unit hydrograph, a triangular 6-hour unit hydrograph with a time base of 50 hours, with time base of 50 hours, with time base of 50 hours, a triangular 6-hour unit hydrograph with time base of 50 hours is formed for a basin of area for a basin of area 120 kilometer square. Okay, two things are asked from you. Find the peak of unit hydrograph, and therefore find the peak of flood runoff hydrograph, or find the peak of storm hydrograph. Storm hydrograph is flood runoff hydrograph only. If base flow is 3 meter cube per second and phi index is, and average loss rate is 0.3 centimeter per hour. Okay, so all these things are given to you. You have to solve it. Okay, now such kind of questions have been asked in your gate examination. This is for 2 marks, this is for 2 marks. So total for 4 marks they have given you comprehension questions. Okay, these are comprehension questions which has been asked for 4 marks, 2 marks each. Okay, so we'll solve it now. Sir, firstly we have a triangle here. Firstly sir, we have a triangular unit hydrograph. Okay, they are saying we have a triangular unit hydrograph. No problem, sir. Okay, sir, this is my triangular unit hydrograph. Base is, how much base we have? 50 hours. Okay, 50 hour base is there. 50 hour base is there. Peak we don't know. We are interested in finding the peak. Sir, firstly we are interested in finding, and tell me the depth, tell me the duration of rainfall. Everyone kindly comment. Tell me the duration of rainfall. Duration of rainfall is 6 hours. Since it is a 6 hour unit hydrograph, obviously the duration of rainfall will be 6 hours only. Okay, is this in clear? Yes, perfect. So this is 6. So duration of rainfall is 6. Yes, no problem. So find the peak first. The first part, find the peak first. So we all know half base into height. Base is, you all know, half into QP into TB will be equal to catchment area into effective rainfall depth. I will apply this formula, sir. Yes or no? Put the values. Half. I want to find QP, sir. Base time is how much? 50 hours. Catchment area is how much? Catchment area is 120 kilometer square. Multiply 120 by 10 power 6, because kilometer square is 10 power 6 meter square. Effective rainfall depth is how much? Tell me effective rainfall depth is how much? Sir, this is your unit hydrograph. This is your unit hydrograph. So obviously if it is a unit hydrograph, the effective rainfall depth is 1. The effective rainfall depth is 1 centimeter. Yes or no? Effective rainfall depth is 1 centimeter. So what will be the peak discharge from here? Yes, perfect. What will the peak discharge? Tell me what will be the peak discharge? How much peak discharge we are getting? Yes, you are saying it is coming out to be, it is coming out to be, when you will solve it, tell me how much you are getting. 13.33. Okay, 13.33 you are saying. Okay, no problem. I hope you have solved it correctly. So QP will be, yes, 13.33 is correct. So the value of QP which we are getting here is, the value of QP which we are getting is 30.33 meter cube per second per centimeter. Why? Sir, because this is big. See, this discharge is because of 1 centimeter effective rainfall depth. This discharge is because of 1 centimeter effective rainfall depth. Yes or no? Tell me. This is because of unit hydrograph. This is because of unit hydrograph. So, because of 1 centimeter effective rainfall depth, the discharge is 13.33. Okay. Perfect. Now, so this is the first part. So, sir, this is my first part. Now I will find the second part. Second part is very simple. I have to find the peak of storm hydrograph. So what I will do, I will simply write the formula. FRH peak is what? FRH peak is unit hydrograph peak, unit hydrograph peak multiplied by effective rainfall depth. See, I am using this formula only. FRH is unit hydrograph peak, then P minus phi t plus base flow. Then P minus phi t plus base flow. I am using this formula only. So P minus phi t is what? Sir, total rainfall is, total rainfall they have given to you or not? In this question, total rainfall is not given. Okay, so we have a problem. Let us say the total rainfall is, 4 centimeters. So 4 centimeter minus phi t. Phi is what? 0.3. Time duration is how much, sir? Time duration is 6 hours because the total rainfall is happening for 6 hours. If 0.3 centimeter water is going into the ground in 1 hour, then in 6 hours 1.8 water will be lost. Yes or no? 1.8 water. Then base flow, add base flow is 3. Base flow is 3 meter cube per second. So how much is the flood runoff hydrograph peak which we want to find? How much is the flood runoff hydrograph peak? Tell me. Yes, whenever unit hydrograph is there, we will write per centimeter because that discharge is because of 1 centimeter effective rainfall depth. Yes, great. Yes, the answer will be multiply 13.33 by 4 minus 0.3 into 6 plus 3. We are getting it as, when you will solve it, you will get it as, when you will solve it, 13.333 multiplied by 4 minus 1.8. Okay. 32.33. Yes, we are getting this value as 32.33. So like this, you will get some questions. Okay, so this is your second part. So this was your first part, and this is your second part. Okay, so I hope it is very, very clear to you. Now, if anyone will ask you how to convert FRH, okay, you can convert FRH to DRH, you can convert DRH to UH. All these things can be converted, but only the equation which you have to remember is this one. The equation which you have to remember is this one. Okay, this is the equation which you have to remember. Is this thing clear? Tell me. Yes, 33.33 is the correct answer which you are getting. Only this much you have to remember. Perfect. Okay. See, derivation part is not important. Okay, so have you understood this? Have you understood this formula? Tell me. Now we'll move on to new topic, which is unit hydrograph of different durations. Now we'll move to new topics, which is unit hydrograph of different durations. Okay, now we have to deal with it. So in this, we have basically two methods. In this, basically, we have two methods. Okay, what are those two methods? Yes, one is your superposition method, and next one is your superposition method, and one is your S curve. Okay, these two are very important topics, so we'll discuss them. We'll discuss only the first one today, and the S curve thing will start tomorrow because it's a long topic. So S curve we'll discuss tomorrow, and tomorrow this hydrograph thing will get over. Okay. Okay, sir. Tell me. So, sir, you are saying if I want to convert my hydrograph. See, why we are interested in finding unit hydrograph of different duration. Okay, why we are interested in finding unit hydrograph of different duration? First, you need to understand the application of unit hydrograph. Okay, see, the main application of unit hydrograph is if we want to find, okay, sir, if we want to find peak, or let us say discharge, if we want to find discharge of storm hydrograph, if we want to find discharge of storm hydrograph, we can use unit hydrograph theory. Okay, sir, how from this theory you will get the discharge? Sir, you have just now told me if you want to get the FRH discharge, simply bring out the unit hydrograph from your lab. Okay, already for all the kind of catchment areas, unit hydrographs are already made. Multiply it by effective rainfall depth, add base flow in it, and you will get the flood runoff hydrograph peak without even going at the outlet. Okay, sir, without even going at the outlet, you can simply get the theoretical value of discharge which you will be getting at outlet. Okay, so if you want to obtain the discharge at outlet at different time intervals without even measuring it for actual, you can bring out unit hydrograph. Okay, let us assume in my catchment 6 hour rainfall is there. So if 6 hour rainfall is there, I will bring 6 hour unit hydrograph. Sir, what I will do, I will bring 6 hour unit hydrograph. I will multiply it by effective rainfall depth. Let us say 5 centimeter rainfall is there in the catchment area. I will multiply this unit hydrograph by 5, and then I will add base flow in it. So multiply unit hydrograph by 5. Let us say unit hydrograph peak is 30 meter cube per second. In the lab, we have obtained a unit hydrograph of 6 hour. Okay, we have obtained a unit hydrograph of 6 hour, and it is having 30 meter cube per second peak multiplied by 5 centimeter because the effective rainfall depth in our catchment area is 5 centimeter. Add base flow it. add base flow to it, and you will get the flood runoff hydrograph. Okay, peak. So this is your unit hydrograph theory. But sir, one problem is there. Now let us assume that in my institute or in my lab, let us say in the institute or in my lab, 6 hour rainfall is not there. Sir, in my catchment area, 6 hour rainfall has happened. Actually in the catchment area, sir, 6 hour rainfall has happened, but we don't have 6 hour rainfall. Sir, we only have 3 hour unit hydrograph. Now this 3 hour unit hydrograph is of no use because actual duration of rainfall is 6 hour. So what I will do, I will convert this 3 hour unit hydrograph into 6 hour unit hydrograph so that I can use it to get the peak again, multiply it again, and add base flow again. Okay, so what is the need here? Yes, I know in gate 2023 S-curve was asked. Okay, you will understand easily, don't worry. Sir, the need to convert unit hydrograph into different duration is that in actual practice rainfall is of different duration and the unit hydrograph which we have is of different duration. So the need is to convert. So there is a need to convert dr unit hydrograph into tr unit hydrograph. Okay, so I'm writing here, if rainfall is of tr duration and we are and we can say dr unit hydrograph is available with us, with us. If rainfall is of tr duration and dr unit hydrograph is available with us, then we will convert dr unit hydrograph into tr unit hydrograph. Okay, sir. Now see, there are two methods. We can convert. See, you need to understand now how I will convert it. See, the first method is method of superposition and the second method is S-curve. Okay, second method is S-curve. Okay, we have two methods. S-curve is little tough and method of superposition is simple. Now in method of superposition you need to understand. See, when I am converting, sir, dr unit hydrograph into tr unit hydrograph, it is important that t is multiple of d, where m is multiple. M is a multiple. Okay, multiple means m is a multiple means 1 2 3 like this. Okay, like this it will be a number. For example, let us take some examples so that we are able to understand it. See, I will use method of superposition only when let us say the duration of rainfall is 2 hour unit hydrograph we already have, and the rainfall duration is 4. So we can convert this 2 hour rainfall into 4 hour. I can convert this 2 hour into 6 hour. I can convert this 2 hour into 8 hour. Okay, because this t is multiple. Okay, this is d, this is t. Now here m is 2, in this one m is 3. 2 3s are 6, 2 2s are 4, 2 4s are 8, like this. M is a multiple. So if we want to convert 2 into 4, 2 into 6, 2 into 8 like this, let us take one more example. If you have 3 hour unit hydrograph and you want to convert it into 6, okay, this is t, this is m. You can convert into 9, you can convert into 12. Okay, take multiples of 3. Simply take multiples of 3. Okay, simply take multiples of 3. This is m, 2, 3 and 4. Okay, so when you have multiple, you can use the method of superposition. When you have multiple, if you want to convert into multiple, if you want to convert a smaller duration unit hydrograph into larger duration unit hydrograph. Okay, if you want to convert, if you want to convert a smaller duration into larger duration, you can use method of superposition. Okay, you can use method of superposition. So I will write that with the help of this method of superposition, I can convert, okay, a smaller duration, I can convert a smaller duration unit hydrograph into larger duration unit hydrograph. Okay, I can convert a smaller duration unit hydrograph into larger duration unit hydrograph. Okay, so this is your method of superposition. Okay, sir, I will solve one example with the help of which all these things will be clear to you. Okay, we will solve one question. We will convert one unit hydrograph using method of superposition. So we will convert 4-hour unit hydrograph into 12-hour unit hydrograph. Okay, we will convert 4-hour unit hydrograph into 12-hour unit hydrograph. Simple. We will solve a very simple question. We will convert 4-hour unit hydrograph into 12-hour. Okay, how we will convert it? Tell me, sir, how I will convert it. So question is given to you. Convert the 4-hour ordinates of unit hydrograph in the table below and derive the ordinates of 12-hour unit hydrograph. Okay, sir. So 4-hour unit hydrograph is given to me. Okay, so 4-hour unit hydrograph is given to you like this: 0, 4. I will write very beautifully here. Okay, so this is 0, 4, 8, 12, 16, 20, like this. Okay, 4-hour unit are given to you. So this is time. You all know this is time, and the discharge values. 4-hour unit hydrograph is given to you. Let me write it as U1. Let me write it as U1. U1 is given to you. So discharge is 0, 5. Okay, let me call it as 19, 25, 12, and 0. So these are the discharges which are given to you. So these are the discharges which are given to me. Okay, so how I will convert it into a 12-hour unit hydrograph? So this is my 4-hour unit hydrograph. Okay, sir. Sir, this is my 4-hour unit hydrograph which is given to me in the question. This is given to me. Only this is given to me, nothing else. This is 4-hour unit hydrograph. Let me draw a graph also so that it is more clear to you. Listen very carefully here. Let me draw a graph also simultaneously so that everything is clear to me. Okay, sir, no problem. So 4-hour unit hydrograph means, 4-hour unit hydrograph means the rainfall has happened for 4 hours only. The rainfall has happened for 4 hours only, and 1 centimeter is the effective rainfall depth. 1 centimeter is the effective rainfall depth. Okay, this is what? This is 1 centimeter. And because of this DRH is there from 0 to 20. We have a DRH from 0 to 20. This is from 0 to 20. Have you understood this thing? These values are 0, 5, 19, 25, 12, 0, like this. Okay. So 4-hour unit hydrograph, because 4-hour duration rainfall is there and 1 centimeter is the effective rainfall depth. Okay. Okay. Good evening, Ayush. Good evening. So this is given to me. Now you need to understand, sir, I have to convert my 4-hour rainfall into 12-hour rainfall. So what I will do? I have to convert my 4-hour rainfall into 12-hour rainfall. Listen very carefully. So what I will do now, sir, what I will do, I will ensure that this rainfall which is happening only for 4 hours, I have to make it for 12 hours. So what I will do, I will take another 4-hour rainfall. I will take another 4-hour rainfall, yes or no? If another 4-hour rainfall is there, then total duration of rainfall will be 8. If another 4-hour rainfall is there, because of that another 4-hour rainfall, we will again have certain discharge at the outlet, yes or no? We will again have certain discharge at the outlet, yes or no? Tell me. Tell me. Sir, if we have one more 4-hour rainfall, then I will again have the effect. See, because of this 4-hour rainfall, you have this effect at the outlet. You have certain discharge at the outlet. Now, we have one more 4-hour rainfall. We have one more 4-hour rainfall. So I will lag it. Okay, that is lagged by 4 hours. Okay, see, second unit hydrograph you will write by lagging it by 4 hours, because that rainfall happens after 4 hours. Sir, this rainfall happens after 4 hours. Okay, so the initial 4-hour rainfall was going from 0 to 20. The effect was effect at the outlet. The runoff was happening only from 0 to 20. Now the runoff will happen from 4 to 24. Now the runoff will happen from 4 to 24. 4 to 24. So I will write all these discharges starting from 4. 0 will be at 4 now. At 8 you will have 5. At 12 you will have 19, 25, 12 and 0, like this. Like this you will have another rainfall. Now the total duration of rainfall is 8 hours. Similarly, I will make one more rainfall of 4 hours. Similarly, I will make one more rainfall of 4 hours. So again you will have an effect. So again, because of that 4-hour rainfall, you will have effect at the outlet. Again you will have the effect at the outlet. You will have certain discharge, yes or no? And that will start from 8 and it will go up to 28. Okay, that will start from, we have to lag again. Okay, so we will lag by another 4 hours, lag again by 4 hours. So that rainfall is starting from 8 hour and ending at 28. So we will write 0 in front of 8 hour. Okay, like this you have to lag. Okay, so I hope this thing is clear. So from 8 to 28, this is from 8 to 28, this is 4 to 24, this is 0 to 20. So this is the effect of first rainfall, first 4-hour rainfall. This is the effect of second 4-hour rainfall. This is the effect of third 4-hour rainfall. Now, sir, I can say the total duration of rainfall is 12 hour. Yes or no? Now I can say the total duration of rainfall is 12 hour in which we are interested. Now I will write, if I will sum them up, I will get 12 hour DRH. If I will sum them up, sir, if I will sum it up, what I will get? Sir, if I will sum it up, I will get 12-hour DRH. Why? Because now total duration of rainfall is 12 hour. But one thing you need to understand, the total rainfall, effective rainfall depth will be 1 plus 1 plus 1. The total, no dear, M cannot be a point value. M can only be a multiple 1, 2, 3 like that. Okay. Now, sir, the total effective rainfall depth is how much? Now the total effective rainfall depth is 3 centimeter. Now the total effective rainfall depth is 3 centimeter. Okay. So this is the first rainfall effect. This is the effect at outlet. These are the discharge values at outlet because of second rainfall. These are the discharge at outlet because of the third rainfall. Third 4-hour rainfall. So 4 hour, 4 hour, 4 hour. Total 12-hour rainfall is there. 12-hour runoff is there. And total runoff is 3 centimeter. Okay. So we will add them up. We will quickly add them up. So add them up. 0, 0, 0 is 0. 5 plus 0 plus 0 is 5. 19, 5 is 24. 25, 19, 5 is 49. Then 25, 12, 19 is, so it is simple. 25, 19 is 44. 44, 12 is 56. Then 12, 25 is 37. Then we have 12 and then we have 0. So when I will add it, I will get a, I will get a graph like this. I will get a graph like this. So this is what? Sir, this is 3 centimeter. This is 12-hour DRH. This is 12-hour DRH of 3 centimeter. When you will combine it. This combination thing we have already understood. But sir, the important point is, sir, I want to find the unit hydrograph. Sir, the point is that I want to find unit hydrograph. So how I will find 12-hour unit hydrograph? See, this is the effect because of 3 centimeter. So if you want to find the effect because of 1 centimeter, what I will do? If I want to find the effect because of 1 centimeter, I will divide these values by 3. Yes or no? Tell me, I have to divide these values by 3, yes or no? Sir, if we have a graph which is because of 3 centimeter, and if I want to get the values because of 1 centimeter, so what I will do? I will divide by 3. So this is the graph finally which you will get. This is the graph which is divided by 3. So you will get 12-hour DRH of 1 centimeter, which is simply your 12-hour unit hydrograph. Okay, so we'll divide all the values by 3. Divided 0. This is 5 divided by 3. This is 24 by 3, 8. 49 by 3, 56 by 3. Like this, you will divide all the values. Okay, 37 by 3, 12 by 3 is 4. Like this. Okay, so these values, what these values are, you will get it here. Okay, so this is how you superimpose. Okay, this is how you superimpose. So now you can understand. Okay, now you can understand why we have to take multiples. See, if this would have been 2.5 times, if we would have to convert 4R into 10R, we could not convert it. Why? Because we cannot lag it properly. If I will lag it by 4R, we will get 8R unit hydrograph. If I will lag it again by 4, you will get 12R unit hydrograph. If I will lag it again, you will get 4, 4, 4, 4, 16R unit hydrograph. Okay, so you need to understand, when I will lag 4R unit hydrograph again and again, I will get in multiples 4, 8, 12, 16 like that. I will get a combined DRH in multiple form. I cannot get it in point form. I cannot get it in fraction form. Yes or no? Tell me. I cannot get the DRH duration. I cannot get the combined DRH duration in fraction form. Okay, if 2R unit hydrograph is there, I cannot get 7R unit hydrograph. Why? Because when I will lag 2 to 2, if I will lag it by 2, I will get 4. When I will lag it again, I will get 6. When I will lag 2, I will again get 8. So it has to be in multiple. So the combined DRH will always be the duration of combined DRH will always be a multiple of the given duration. Okay, so this is how you convert. So you can convert 6R into 12R. You can convert 6R into 12R by simply lagging it once. You can convert 6R into 18R by simply lagging it twice. Okay, you have to lag it twice. You can convert 4 into 12 by lagging it twice. You have lagged one time, so you have lagged 2 times. Now one thing. Now you need to understand, when you have converted 4R into 12R, the base time initially was, see, in 4R unit hydrograph, sir, one thing we need to understand, in 4R unit hydrograph, the base time is how much? In 4R unit hydrograph duration, the base time is 20. You can see the base time. The effect of this is 20 hours. Can you tell me what will be the base time for 8R duration? Now if you will convert it into 8R unit hydrograph, what will the base time? Can you understand? See, when I will lag it again by 4 hours, so this base time will increase from 0 to 24. Only 4 hour will be added because I will lag it once again. If I want 12R unit hydrograph time base, 12R unit hydrograph time base, I will lag it 2 times, 4, 4, 4, 4, 4, 12. So I will lag it 2 times, 1 time and 2 times. In this case, the base time will be from 0 to 28. See, 0 to 28. The graph which you are getting is from 0 to 28. Okay. So if you lag it 1 time, add if you lag it 1 time, add 4 hours in your base time. If you lag it 2 times, again add 4 hours in your base time. So base time increase like this. Okay, so if you want to write the general formula, let us say TV dash is the base time for, let us say TR duration, TR unit hydrograph. And if you have TB is what? TB is the initial base time. TB is the base time for DR. TB is the, let us say, base time for DR unit hydrograph. Then what we have to do? We have to add m minus 1 times d. Okay. So let us consider our example. In our example, the base time initially was 20 hour, but since we have lagged it 2 times, okay, since m is, see, if you want to convert 4 into 12, m is 3. But if m is 3, you will lag it 2 times, 1 time and 2 times. M is 3, but you will lag it 2 times, 3 minus 1, and multiply it by 4. So 2 into 4 is 8. So that's why you will get it as 28. 244. 20 plus 4 plus 4. So you will get it as 28. So base time for 12-hour duration is 28 and base time for DR unit hour is 20 hours. Okay, so is this thing clear? Tell me if all the concepts are clear to you. Then we'll end our class today. Tell me. This base time thing is clear? So this is how with the help of method of superposition. This is how with the help of method of superposition we convert DR unit hydrograph into TR. And T should be a multiple of D. And T should be a multiple of D. Okay. So is this thing clear till here? So everything is clear. So if I want to find the relationship in the base time, so this will be the relationship. Okay, so this will be the relationship for your base time. So base time increases. 1 lag, 4 time will add. 1 lag, again 4 hour will add it. Again 4 hour will add here. Okay, so this is the end. We'll end our class today. Here we'll end our class. Okay, now we'll catch up tomorrow, and tomorrow we'll discuss the S curve. Okay, that will be the last topic of your basically hydrograph. After that, only very small topics, flood routing will be left. So we'll discuss it. Okay, so thank you everyone. Stay blessed. We'll catch up tomorrow with S curve. Take care. Good night everyone.